Welcome to solving a system of equations in two variables. We're going to look at solving a system of equations in two variables by graphing, by the substitution method, and by the addition method. So first, let's look at graphing and how we could look at a system of equation in two variables. So we could have three things happen when we're solving a system of equations in two variables. We could have the case where we have one solution. That's where line 1 and line 2 intersect each other. Or if line 1 and line 2 are parallel, that is, their slopes are the same, we'd have no solution because they'd never cross one another, definition of being parallel. And then infinite number of solutions if we have the same line. So we're going to look at all of these cases. So the first thing we're going to do is we're going to solve a system of equations in two variables by actually graphing linear equations. So let's look at the equation negative 2x plus 3y equal 6 and 2x plus 3y equal 18. What we have to do is graph both of those equations and see if they intersect, and if they do, find the point of intersection. So I take equation 1, and here's I take equation 1 and equation 2, and what I'm going to do is I'm going to solve for y. I'm going to put it into y equal mx plus b form, where I can have the slope and the y-intercept and be able to graph that equation. So equation 1, what I'm going to do with it is I want to solve for y. So I'd have to add 2x to both sides. I'd get 3y equal 2x plus 6. Now I'd have to divide by 3, so I get y isolated. So when we divide by 3, I'd have to divide the 2x by 3 and the 6 by 3. So I'd have 2/3 x plus 2. So my slope is 2 over 3. It has a rise of 2 and a run of 3. So I know that this is my y-intercept. That's how we write the y-intercept. When x is 0, y is at 2. And now I can use my slope to find other points on the line. So I could go up 1, 2 and over 1, 2, 3. So my slope is 2 over 3, or I could use negative 2 over negative 3. So I could do my starting point and go down 2 and over negative 3. And I have my equation of the line. Now I've done line 1. So I could call it y1, and then I can now do equation 2 and graph equation 2. So I'm going to do it over here. Here's my equation 2. It's 2x plus 3y equal 18. So in order to isolate y, I have to first get x on the other side of the equation. So I'm going to subtract x from both sides, the negative 2x from both sides. And I'd have 3y equal negative 2x plus 18. Now I'm going to divide both sides by 3. That means I have to divide 3 into this negative 2x and 3 into 18. So I would get y equal negative 2/3 x plus 6. That means my slope is a rise of negative 2 going down 2 and positive 3 going over positive 3. Or I could write it as going up 2 and going over negative 3. So I'm going to use this y-intercept once again to find my points. So the y-intercept is 0, 6, or you could even see if I put 0 in for x, I'd get y equals 6. I'd get that point. So I go to 0, 1, 2, 3, 4, 5, 6. My point would be up there. So you know what? I'm going to change colors. So it tells me I have a, let's use this one, a rise of 1, 2, and a run of 1, 2, 3. Right now I see a point where they intersect. So I only need 2 points to draw a line, I could draw my line, but I see where they intersect. They intersect at the point 1, 2, 3, 1, 2, 3, 4. So the point 3, 4 is what solves my equation. In other words, it's a point that solves both equation 1, that is, makes it true, and equation 2, that is, their point of intersection. If it has only one point of intersection, we call it consistent. So it has one solution, so it's consistent. And I can give you that point of intersection. Now, I'm going to give you a problem to do. I want you to solve by graphing this problem. So I want you to solve this system of equations, these two equations with two unknowns, by graphing. If you'd pause the video, so now I'm going to work out this problem with you. X plus y equal 12. Negative x plus y equal 4. So what we're going to do is we're going to take these, we're going to solve both of these equations for y and graph them and see where they intersect. So here's equation 1, here's equation 2. So I'm going to make my coordinate plane, and I'm going to take equation 1 and solve it for y. So I would need to subtract x from both sides, and I'd have y equal negative x plus 12. So there's equation 1. My slope, there's an understood 1 there, so my slope is negative 1. So I could either use negative 1 over 1, rise of minus 1, run of positive 1. That means I go up or down negative 1. So I'm going to go down by 1, and I'm going to go to the right to the positive 1. Or I could think of this as 1 over negative 1, going up 1 and over negative 1. With my intercept being 12, 0, 12. So I graph on my graph, here's my y and my x, 0, 12. And now I'm going to use my slope, negative 1 over 1, negative 1 over 1, or I could go up 1 over 1. But I really only need 2 points to make a line, and then I make my line. So this is equation 1. Now I'm going to look at equation 2, and once again I'm going to solve for x. I'm going to add x to both sides, and I'd have y equal x plus 4. My intercept is 0, 4, and my slope is 1 over 1. Or I could say negative 1 over negative 1. And now I'm going to graph that. So I have 0, 1, 2, 3, 4. And I have a rise of 1, a run of 1, rise of 1, a run of 1, rise of 1, a run of 1, rise of 1, a run of 1. So I mean, if I did all those points, I really only needed 2 to graph this. But in doing that, we clearly see where they intersect. So when graphing a line, you truly only need 2 points, and you draw the line, and you could clearly see they intersect at 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So this is consistent. It has 1 point of intersection. So now we're going to look at this system of equation and work with this one. So if I take my first equation and solve for y, so here's equation 1 in green, equation 2 is in red. So I'm going to solve equation 1 for y. So first I'd have to subtract 3x from both sides. Negative y equal negative 3x plus 1. And since it's got a negative coefficient, negative 1, I'm going to either divide or multiply by negative 1, whichever way you like to think about it. So I'm going to divide by negative 1. Y would equal negative 3x over negative 1 would give me that positive 3x. 1 divided by negative 1 would give me a negative 1. Okay, just changing the signs on the whole equation. My y-intercept, 0 minus 1. My slope, 3 over 1, or I could think of it as negative 3 over negative 1. So I'm going to first graph my y-intercept, 0, minus 1, and then I'm going to use the slope. Up 3, 1, 2, 3 over 1. And now I can draw in my line. Now it's time to look at my equation 2. 3x minus y equal negative 7. And I'm going to solve this one for y. So I have to subtract 3x from both sides. And I'd have negative y equal negative 3x minus 7. And then once again, I could multiply by negative 1 or divide by negative 1. This time I'll multiply by negative 1. And when I do that, all the signs change. So I'd have 3x plus 7. So I have a y-intercept of 0, 7, and a slope of, 3 over 1. Or I could think of that as negative 3 over negative 1. Our slopes are the same. We have parallel lines. This is going to tell us that we have an inconsistent, that there are no solutions because parallel lines never mix. So even as I plot this, I'd go to 0, 1, 2, 3, 4, 5, 6, 7. I use the slope of 1, 2, 3 over 1. And then when I draw my line, you're going to see parallel. And we know that they're parallel because their slopes are the same. Therefore, there is no solution. And if it's consistent to find a solution, if there's no solution, we say it's inconsistent. But if you just say there's no solutions, that's just fine. Now, when we have these, we're going to solve these for y and then graph them. So I take equation 1 and I'm going to solve it for y. So I'd have to subtract x from both sides, and I have y equal negative x plus 4. And I could graph it. So y-intercept and a slope of negative 1. So I could rewrite that as negative 1 over 1 or as 1 over negative 1. And why do I put it the negative with the numerator or denominator? Because it's a different way you could use the slope to find different points on the line. So I start at 0, 1, 2, 3, 4. And I'll use negative 1 over 1. I've got 2 points, and now I can graph the line. Now I'm going to do equation 2. Solve for y, so I'm going to subtract 3x from both sides. So I have 3y equal negative 3x plus 12. Now I divide this side by 3, and I divide that side by 3. So y equal negative 3x over 3 plus 12 over 3. Or y equal, look at this. These are identical lines. So when I graph it, every point is the same on these two. So this is where we have an infinite number of solutions because they're the same line. So when there's an infinite number of solutions, we say the lines are dependent. The equations, the lines, are said to be dependent. So we have consistent if there's one solution, inconsistent if there's no solutions, in other words, parallel lines, and dependent if they're both the same line. So this concludes part 1 of solving systems of equations, where we graph. Now, I said at the start of this, we're going to learn how to solve system of equations by graphing, by substitution, and by elimination. So in the next video, we're going to do substitution. Thanks so much for watching.